Hello everyone and welcome to a webinar on Tux Magic Hack Tricks for Linux Persistence. I'm Nandini Bharadwaj, the operating officer at CyberWarFare Labs, and I'm really excited to have you all here with us today. So let's get started. So before we start, let me give you a little introduction about us. So we are CyberWarFare Labs, a UK-based focused cybersecurity education company. Our goal is to help people tackle cybersecurity challenges with practical solutions. So we have got two main divisions to our company. The first is CyberRange Labs. This is where you get hands-on experience with cybersecurity. We have built a virtual platform where you can try out real-life scenarios and sharpen your skills with practical exercise. The second one is upskilling platform. Here, we offer a bunch of courses for people at all skills level. Whether you are just starting out or you're a seasoned pro, we have got something for you. Our courses cover domains like ethical hacking, red teaming, blue teaming, purple teaming, and cloud security. Our training services are also available to educational institutes, government agencies, and corporate organizations. Both online and offline training options are available. So if you want to know more, drop us an email on support@cyberwarfare.live. So that's all about the company. Let's move to next slide. Okay, so let me introduce to our speakers of today's webinar, that is Abhijit Kumar. So Abhijit Kumar is a security researcher with expertise in red team operation, network security, cloud infrastructure, and Linux system. He is also passionate about researching adversarial tactics, techniques, and procedure, and frequently experiment in his home lab. So that's all about our speaker, and we are excited to hear his insights today. So, dear participants, as promised, we are excited to share that you will receive your attendance certificate within next 48 hours, along with the video recording of the webinar. And a lucky winner whose comment got the most like will get access of our bestseller course that is Certified Process Injection Analyst. And if you want to participate in the giveaway, I'll drop a link in your text box, and you can just follow the written steps to win this course. So yeah, thank you for being part of this webinar, and we'll look forward for your continued participation. And here, without further ado, I would like Abhijit to take over, and let's get started. Okay, over to you, Abhijit.
Welcome, guys and girls. Today we are talking about some Linux persistence tricks and how we can execute them in a stealth mode, as well as how we can detect. So we will also be touching upon some of the common detection methods using native commands as well as OS query. So let's start. This is our agenda. So first we will be touching upon the Linux 101, where we will just be looking into Linux and some of things. Then we will talk about persistence for a minute, and then we will dive deep into the techniques. So these are the techniques we are touching upon: profile files, user accounts, SSH authorized keys, cron jobs, systemd service files, kernel modules, and shared libraries. So let's begin. So Linux. While most people talk about Linux like this is Linux, but actually Linux is kind of a kernel, and various distros are built on top of it. So if you say Ubuntu or Debian or Fedora or whatever, so that is kind of a distro that is built upon the Linux kernel. So that is the basic of Linux, and it's mostly a kernel, and we are building a OS on top of it. This is something very interesting and very preliminary kind of thing. So these are some of the directories that are available whenever you access any of the Linux distros, be it your Fedora, Red Hat, Arch, whatever. So bin boot. So in the bin directory, there are some of your executables or configuration like executables. Then boot is related to your booting files, like your grub files are there, dev, etc. Like these are the files that are present on your kind of your file system, and some of these are very important because these contain actually the main files that are required for the working. So one such directory is your etc, where your configuration files are stored. Whatever configuration files you're having, it will be stored in your etc if it is a system wide. And then there is your home directory where the user accounts and the user files are stored. So these are some of the directories, and we will be looking into some of these at a later point. So let's move. So what is persistence? So usually when we talk about end-to-end cyber operation or red team operation, it involves various stages. So it usually starts with the reconnaissance, that is your OSINT or your active reconnaissance, which is your enumeration, and moving on, like when we get initial access to the system. But what happens after we get initial access? So we need some way so we can persist in the system. We need some mechanisms or some methods or some uh, tools through which we can gain consistent access to the system. Because let's say if we are getting access to a system, but if the owner reboots and we are kicked out, so we have no way to kind of get in. So that is why we install some sort of mechanisms through which we can gain a constant command access to the system, whatever system, be it Linux, be it Windows, be it Mac, or be it Unix. Doesn't matter. This is kind of the thing we do when we are talking about the persistence, and usually we do it after we kind of do the initial access. So when we get initial access, we can use some of the techniques to gain persistence. However, if we do not have the higher privileges like root privileges in the Linux-based systems or the admin privileges in your Windows-based system, so essentially we cannot execute some of the trickiest or hard to detect techniques. So, whenever we are talking about the persistence, usually we can do it either right after the initial compromise, or we can simply gain some privilege escalations. We can gain some higher privileges and do some sneaky kind of things, which are tricky to detect. So this is the first technique we will be talking about. So this technique is the profile files. So in Linux, whenever we are creating an account, or whenever we are logging into an account, or whenever we are kind of initializing an account, so some sort of scripts get executed. So these scripts usually kind of configure the profiles, configure the minor settings, they tweak some of the things, and kind of make it ready for the user to use. There are two ways usually we can do this. So either we can reboot the system, so it will be auto initialized, or we can normally use, like if we made some changes and we want it to be happen instantly, like instantly without rebooting. So we can use the source command. So there is a source command through which we can kind of initialize the profile instantly. And some of the locations for this profile files include the bash rc, bash profile, and if you look into the etc, so there is a profile.d directory. It also contains it. Actually, this profile.etc, profile.d, it contains your system-wide configuration. While these, this tilde and like forward slash dot bash rc and the profile, these are kind of the user level. So whatever changes we make to these two, like bash rc and profile, they are only restricted to the user we are executing it for. But if we modify something in the profile.d, it is actually system wide, so it will be done for all the users. So let's look into the demo. So we do have a few demos here. And before demo, I just want to say one thing. So we will be doing some live demos. There will be some live VMs. We humbly request you not to attack these VMs. Just enjoy and kindly refrain from doing nefarious activities. That said, let's look into the demo. So here we have our C2 server, and here we have our victim server. So in the C2 server, we are gonna start a listener. For this listener, we will be using SOCAT. So for SOCAT, we have couple of the files here. So in all of the demos minus one, we will be using the SSL, like open SSL encrypted communication channel. In one of the demo we will be using plain text channel, and I'll explain when we'll get there why we are using the plain text there. So with that said, let me type out the command, and do appreciate your patience for just listening and giving me chance to type out the commands. And it happened. Apologies in advance for this. Oh, I forgot I had these in here. So we have started our listener here. Now we will go to our victim machine, and in victim machine, let me do one thing. Let me do nano dot bash rc. So if you look here, we have one line here. It is SOCAT OpenSSL. We are connecting to this IP with on this port, verify equals to 0, and execute is bin bash. Essentially, what we are doing is we are executing this command. So it is SOCAT is a very good alternative to Netcat. So recently, Netcat has removed some of the features like tag E and tag C. So for this purpose, demo purpose, we will be using SOCAT. It is not a requirement. You can use whatever C2 or whatever listener you want when you are on an engagement or just playing CTS for the fun. As I had mentioned before, so we can use two methods. First is this rebooting, or second is sourcing the file. So we did source. If we go to our C2 channel, C2 server, we can see okay, we got a connection here. Ubuntu, let's test the host name. So it's Linux persistence. We can see it's the host name is Linux persistence, and if we go here, we can see okay, so the host name is also the Linux persistence. Now talking about the detection portion. So there are few ways we can do this. So first is a very simple net start. We can do net start. Uh, Net start A. We saw the port which the C2 was using was 1337. So we can use this net start A grep 1337. So it will grep. It will tell us okay. So this is running here. This is the instance. This is the IP connection established, and this is the kind of the port we are using. This is the port the server, the C2 server is using. Another good way is OS Query. Actually, I was introduced to OS Query just a couple days back when I was talking or more like brainstorming with one of my colleagues regarding how we can detect these things. And he said like you can use OS Query, and I had heard of it but never used it. Now I am using it, and I find it very easy to use if we are dealing with a single system, that is, because it can only be installed in a single system, and we only have to use the command line to do it. There are some ways. I have read some blogs, like I think they were using some tools to kind of automate it, but anyways, that is out of the scope of this one. So select star from process open sockets where remote port equals to 1337 and this. This OS query, it also uses your native system commands. In this case, I'm pretty sure it is using netstat for pulling these informations, but still it's a very kind of a centralized and very good way to um, kind of pull up the data. So in this case, we do not have to remember the multiple commands, multiple strings. We just have to kind of create a cheat sheet and just kind of copy paste these commands. So here we can see the connection is established. This is the local IP. This is the remote. So this local is for this system only. This remote system is our C2 server. This is the local port through which we are connecting. This is the remote port connection established. This. So this was the OS query, and this was the first demo. Let's move back. So second is the user accounts. So mainly these accounts are of two types. We can either create a local account which we use, use to log in, and then we have the service account. So it is also similar to kind of our in if we refer to Windows, we have our admin account, we create a user account, then there are some system accounts like Kerberos and some other accounts. So these are also the same kind of thing happens in the Linux. So in Linux we also have a kind of a different um, accounts. We have the local accounts which we create to log in. We have service accounts, like if let's say we install a software such as we install Apache 2, so it creates an account triple W data. Or if we are installing another software, let's say we are installing something like Elk, so it creates an Elastic account. So these are the system accounts. So the main difference between the local accounts and system accounts is we can interact with local accounts using the bash shell or whatever shell we are using, but on the system accounts, they are by default they're restricted, so we cannot use any shell, and this is to prevent kind of the remote access to the system. So with that said, let's look into um, demo slide. Okay. So let's look into some of the other things. Before this, let me do one thing. Let me quickly comment out this shell, because some issues will happen if we constantly run the multiple shells. Okay. So here is a very interesting thing. So if you look at this third column, this is your third column. So this is your username, this is your login kind of thing. Like this is your password placeholder. This is kind of your UID that is assigned. So here is a thing. Like if you look at this one, so I have been logged into this with this account. This is Ubuntu. We can see like it has a UID of 1000. So if we are using a system account, so the UID will always be less than 1000. It will be, let's say, 0 in case of root, or 8 in case of mail. So it will always be less than. And if you are creating a user account which is used for interaction, so it will be kind of more than 1000. Like 1000 will be your default, and others will be above that. So actually for this demo, I have created one account here. This is the account EC2 AWS sync, and I have given it this 998. So let me show you how we can do this kind of thing. So we are simply using the user add command. You are using R, which is kind of with this R we are denoting that this is a service account we are creating, and we are using S. So we are giving it a shell. So we are giving it a user bin bash. We are also adding this account to a group. So by default, we are adding it to a sudo group. So sudo in this case is 27 in the system. And let's say we are creating our demo user. Okay, I did this demo user. And let's run this etc password again, and we can see like we have a demo user, and the this UID is kind of 997, which is again the system account kind of. But we can see like this is it has a bash cell, so this user can log in. So just for the demo of this, let's do something like this: sudo shu demo user, and we can see like we have logged in as a demo user. Okay. So for direction of this, we can use some simple command. So first is we can do something like grep at cat etc password. We can check through this manually. So we can check manually whether whether these accounts have these kind of shells. If they have shells, it means that it has a persisted. It can access the system using the bash or any shell. Or we can again go to our friend OS query. We can do something like this. Just a minute. Wait. Select star from users and where UID is less than 1000. So if we run this, we will again see that there are these accounts which has a UID less than 1000, and we can see like we created this account just now, this demo user. I created this one previously, so we can see like these accounts also have this ID, like this UID less than 1000, and they are in this. And if you check, all of these are system accounts. Like we have the TCP dump, we have the SSHD, and we can see like all of these have a kind of a low number of UID. And there is one another way to test this. So in this one, we are checking for users with the kind of the UID which is less than 1000. But there is another way. Select UID, username, directory, shell, from users, where shell is not equal to user has been no login. So let me run this first. Now I'll explain. So basically with this command, we are selecting users where their shell is not matching this no login. So if you check here, in all of these except the root, we have the shell set as user has been no login. It means this account is not permitted to login. But if we are running this, we can see that root is having bin bash, sync is having bin sync, TSS and these are having bin false. So it essentially false is zero. So it is essentially invalid. So it is also not allowed as per as I know. And then we have the user Ubuntu, which is having bin bash, and we have these two users which are having user bin bash. So this is another way we can detect if someone logged into the system, and if they created an account with a like with a persistent kind of setup. So we can use OS query to kind of filter out and kind of detect these kind of things. Moving on, SSH authorized keys. So when we are using SSH, we usually have different methods we can use. So first and most common one is using the passwords. But apart from passwords, there is one very strong way to kind of do this, which is the public key infrastructure. So it is PKI. So we are essentially using the key pair, like that is our public key and private key to SSH. In this case, public key is stored into the machine, where we are trying to log in, and the private key is stored on the machine from which we are trying to log in. So this is a one very neat way to secure a system, because in this case, if we are only using the public key and private key combination, and if you are denying the password, so no matter whatever the attacker, they might try brute forcing, but it won't work unless there is some vulnerability, that is. So let's look into some of these things, and I'll show you quickly. Let's move here. So we have this authorized key file here, and in this file we have two keys added. Two public keys are added here. So these are public keys, and the private key is stored in whatever system is accessing this particular VM. So in this one, this demo project, one of the keys is stored in the system where from which I'm logging and sharing the screen, and the another one, it is actually installed in the this key is actually installed in the C2 server. So let me quickly show you, and let's end this. So you can see like there are two key pairs. One is IDRSA, one is IDRSA.pub. So this IDRSA.pub is what we have essentially put there, the content of this IDRSA.pub file. So now what I can do is, since I have already added to this one, I can simply run something like this: SSH Ubuntu at the rate of the public IP. So it is 51 dot as not speak. So you can see like we simply logged into this particular system with just kind of just simply adding one liner key, and there are some settings we can modify in this before looking into the direction kind of things. So if we look into this, we have several files, and this is what I was talking, like if we keep these persistently active, so these sort of things like kind of happen. So I must have left it somewhere. So in this one we have configs. We are mainly interested in this SSD config. So in this one we can see like we have different configuration options, and if we scroll down, we have here permit root login, and we have one here that is public key authentication. So if we have enabled this, and if we are simply using a key, so what we can do is, instead of root login prohibit password, we can write no. And if we scroll a bit down, so here it is written password authentication is yes. If we turn this to no, so this system will completely be kind of at least brute force proof in some regards. Anyways, now let's talk about the direction. So again, we will be turning to our faithful friend OS query. Select authorized keys, star dot star, sorry, from users. We are also joining another table here. If we run this particular command, we can see that it pulled up all the details of all the kind of the SSH keys that we have added. So in the first one, this UID is 1000. So UID 1000 is again for the Ubuntu user. If we are adding this to another of the user, so it will be something different. So it will be the UID of that particular user. This is the algorithm we are using. So we are using actually RSA. There is another, I think, ED 25519 or something. So that is a very good algorithm and very painful. I still remember my cryptography classes. So again, moving on, we have this key. This is the public key. This till LD here, and this is the demo project. This is the name. This is our Ubuntu C2 server. This is the key we are using here, and this is the location where this key file is stored. So this was kind of the detection for this. Let's move on. Now moving on to cron jobs, and it is kind of one of my very go-to things when I'm using a server myself, like not for the kind of the persistent or attacking purpose. It is just a kind of a very easy way to kind of schedule things. So let's say if I have a server, if let's say I'm running a website there, and let's say if I want to back it up every 1 hour or every 2 hours, so instead of doing it manually, what I can do is I can simply create a script. I can simply add that script to my cron tab. I can set the timer, and whatever timer I'm setting, it will be running the script at precisely the very same time. So it is actually something that is mostly used by sysadmins or sysadmins, or kind of the power users which who automate the system, who automate some of the tasks. So another example for this would be, let's say you are running a system, and let's say you want the system to update every time you boot into it. So you can create a script which will be containing your sudo apt update or whatever, yum update or dnf update, or then you can use that script. You can write a cron tab, you can schedule it at the rate reboot, and it will be executed at every reboot. So moving on, again let's go to this. I'm listing the cron tabs. We have one cron tab here. It is right now commented out. So let's and before this, let's run our listener here. So we have started the listener. Now we will be editing the cron tab. So essentially, what this cron tab is doing, there are five asterisks, right? So one of these asterisks is for minute, hour, day. It is like there is one very good website. It's crontab.guru. I'll speak CRONTAB.GURU, and me or CWL, we are not affiliated with this website, but personally I use it whenever I'm writing cron tab. It's very good. It has very decent examples. So if you want to check out how to write cron tabs, or how to look into cron tabs deeply, so that is a very good website you can do. So right now I'm doing this. So this is the job I'm running. This SOCAT, this executable, this thing is what I'm trying to execute every minute. I have edited it. Now we will move here. Um, it will be coming here very shortly. So since it's not here, let's talk about some of the other crontab files we have. If we do this, we can see like we have different directories here, like minus the script one. So we have cron d, cron.daily, hourly, monthly, weekly. So we can configure these kind of scripts here. Meanwhile, let's look into this. We can see like there is one EC2 scrub.all. So I think it is something that is created by AWS whenever they are kind of running some scripts. And meanwhile, we can see like we got our connection here. Again, we will run who am I? I'm Ubuntu. Okay. What is my host name? Not his name. And this is a non-PTY shell, so it can be upgraded, but let's not do it for this demo. So we can see like Linux persistence. So again, we got the shell just by using editing a cron tab. So let's comment it out. Now for the detection of this, um, one detection that we can do is what I just showed before. So cron tab tag L, it will show you the cron tab for this particular user account. I tried using OS query to do this, but at least for this particular cron tab, OS query was not able to do it. There might be something complicated script to do this, but right now I do not have the script for this. So if we run this, select start from cron tab, we can see like different cron tabs are scheduled here, right? Day of the week we saw one at c scrub or something in the cron.d directory. So if we go here, if we do this, so we can see like there is one, this scrub all, right? And if we go here, so we can see like this is here, it is set to run every 10 minutes or 3 hours. So I think every 3 hours and 10 minutes. So this is this, and we can see like here is anacron. So here is a very interesting thing. So cron, that is your cron, it is basically designed for the servers. So it is designed for the servers which are expected to be running up and running continuously 24 into 7. But if we are running on a host system, like let's say our laptop or some other system which is not up most of the time, we can use this anacron. So it is also available in the repositories like be it apt or like yam or dnf, so it is available. So it is mostly targeted towards the systems that are laptops or desktop which are not running 24 into 7. So this is anacron used for personal systems, and cron is mostly used for the servers. So that was that. Let's go back. And systemd service files. So whenever we are installing a service, any application or any tool, so usually it creates a service file. So this service file is that's application's way of telling the system that I am this service and these are my requirements. So if I am failing, restart me at this time, or these are the conditions you have to do, like when to start me or when to end me. These are kind of the configuration this the application installs by itself to tell the system. So the locations are this etc system d system and this etc system d system default target mode. So this second one is, I think, in case you enable it. So enabling it means you are kind of enabling it so that it is accessible whenever a system is rebooted. That is my understanding. I could be wrong, but that is why what I understand for this, like default target ones. And for this is your directory where every service file is stored. So before moving on to the demo, let's look into something. So this is a kind of the Linux boot process, which is a typical boot process concerning the systemd. So before systemd, we had init. It is still like systemd init. It is still being used at some OSs and some distros, but the difference is systemd init, it used to kind of execute with the run levels, but this sysv init, sorry, sysv init, it used to run with the run levels, but the systemd it kind of changed the game, and it is kind of having its files and the configurations, and it is a very good way to kind of configure if you are running a fleet of systems. So, anyways, let's look into the boot process. So, first, whenever we are turning on this laptop or whatever system, so first we have our post, that is your power on self test. So, it checks whether you have the peripherals attached, whether everything is working, whether you have power or whatever not. Then it loads the MVR, which is your master boot records. So MWR is your master boot record, which contains the boot entry file. So it actually contains the location of your boot file. MBR in turns loads the grub2. So grub2 is the newer version of the grub, which was kind of the predecessor to this booting system grub. So right now, in almost every modern Linux distro you use, you will see the grub2. It will be something like grub2 tag abcd.xyz. So once the grub2 is loaded, it loads the VM Linux kernel image. So this VM Linux is kind of the you can simply understand it as a statically compiled with symbols of a kernel image. So we have a kernel, like previously I mentioned that Linux is basically a kernel and distros are running on top of it. So this VM Linux, it is kind of a static version of that kernel, and it is also loaded with these symbols, kind of the debugging symbols, and then it extracts the contents of your init RAM file system. After this, it moves to the kernel where it loads the initial driver modules from this init RAM file system. So these modules could be your peripheral systems, your block drivers, your character drivers, and we will look into these a bit later. So meanwhile, like once that is done, so it starts the first process, which is the system D. So this is very critical thing. So whenever a system is booted, even before starting the user processes, the first process that is started is the system D. So essentially, if we can compromise a system at this level, sorry. So essentially, if we compromise a system at this system D level, we essentially have kind of a rootkit comparable privileges. Kind of. It is not kind of rootkit. It is detectable. It is kind of easily detection and mitigation is very easily possible. But it is a very kind of first system. Of obviously, it is secure, but we can always find kind of ways to you know kind of skedaddle through the defenses. Anyway, so once the system D is loaded, what it does is it reads the configuration files from this directory. This directory is kind of the directory where all of your files are loaded, like stored. Doesn't matter whether it is started, it is enabled to run at system start. It doesn't matter. Every file is there. Then it reads file linked by this default.target. So we kind of looked into this one default.target.mons. So this default target, it is essentially the configuration. It contains the configuration files which are supposed to be restart not restart which is supposed to be started whenever a system is rebooting. So to give you an example, let's say you're running SSH. Okay, so you want your SSH to be running whenever a system is rebooted, but how will your system know ki when to start the SSH or whether or not to start the SSH? So we are creating the configuration file, we are linking it, we are enabling it, and it is also done automatically whenever you're installing OpenSSH server or client, like or the meta package from the any repositories. So it links to this default.target.wants, and it says I want to be restarted whenever a system is rebooted. So that said, let's look into the demo. So for first demo, I had previously mentioned that there will be mm, one demo where we will be using the plain text SOCAT. So this is that demo, and that is simply because I was trying to make this work with the Open SSL, but I was getting a lot of errors. So I decided to simply go with this simply plain text one just for the purpose of demo. Okay, so here we can see like this is the HC system, and we have different service files here. And most of these files you will see are linked to this one libsystemd. So this libsystemd is kind of your default location for your important service files, but for the demo purpose we are simply using here. So I have one file here, that is rev shell. If I run this, it is a very simple file. We simply have a unit which is describing like what is this file about. We are defining a service block where we are defining what type of service and what configurations we want. And this is this, and exec start is this command, and then we have install. So for which user we are installing. So if you look into this multi-user target, so this is essentially your CLI based system. So this multi-user target is kind of the configuration or kind of your directory which is essentially responsible for the CLI based services or CLI based files. So right now I have started here the listener. You can see like we haven't gotten anything here yet. Now I'm simply gonna start this revshell.service. I did this and we got a reversal here. Again running who am I, Ubuntu, hostname, Linux persistence. Again, we managed to do this similar thing with another method, and this is kind of one of the uh, sneak. No, I will not call it sneaky, but I will call it if you know what you do, what you are doing, and if you are ready to kind of troubleshoot the errors. This is a very good place to kind of install a persistent binary or persistent trick because it is essentially a system file and there are very less ways to kind of detect this. And again I'll show you one other thing, so let's see SSH. So this is the SSH service. We can see like there is a one unit block. If this is finding, this is the description, this is documentation after. So here it is something very important thing. So after network.target, so essentially when things are loaded into the like kernel, whenever systemd is active, so some services are started first. So network.target audit.sys service. So this audit is kind of your auditing system for the system. You can call it like kind of the event logger kind of thing. This network.target is essentially your network drivers or your network devices which are brought up. So it is we are essentially this is defining that start me after this network dot target. So once the network is up, only start me then, and again only start me after the network and the audit services enabled. And then we have different files like different sorry commands like exec start pre this restart on failure. So we will not be looking into these files. That is a bit out of the scope of this particular demo. And since we have the screen full, so let's clear it. And again we are gonna kind of use OS query to detect. So now if we run this OS query command, we can see like we have a lot of data to actually pass through. Our this rib shell will be somewhere here. I'm just trying to figure out where is it. It will be somewhere here. Rib shell I saw. SQ shell. Uh, it's here somewhere. Anyways, I couldn't find this one. It should be somewhere, but anyways, let's look into some of the things. So we can see like there is a cron.service, which is a service file for our cron tab. We have the SSH somewhere here, and we also have the drivers. Like we have SSH here, somewhere netplan is for ubuntu network configurations. We also have some drivers here, so ssh is there, cloud init is there. This is the user initialization, and we can also see like poll kits, and we'll also see some of the drivers. I saw keyboard driver here somewhere. So essentially these service files are very kind of system is pretty much dependent on these service files in order to kind of do better job of starting or not starting but managing other services. So this was for this. Let's go back. Now kernel modules. This is, to be very honest, by far the one of the toughest as well as one of the sneakiest kind of persistence technique I have so far found. And it is so sneaky because essentially we are operating at the kernel level here. So anyway, so defining the kernel module, so it is a kind of the piece of codes compiled, or you can see compiled code, which can be injected into the running kernel or whenever the kernel is started. So essentially it is kind of the you can kind of perceive it as an extension to the kernel, some of the features or some of the uh, advantages, not advantages, but some of the configurations or some of the add-ons to the kernel. So essentially, why we require this is, let's say you are getting a vanilla kernel, let's say you're using Debian, and let's say you have a USB driver, like you have a USB adapter for which the driver is not yet supported into the kernel. So in that case, what you can do is you can write your custom, driver for this. You can inject it into the kernel and kind of use it. So that is kind of the one of the purposes of this these kernel modules. And some tricky things which actually revolve around this is, essentially, since we will be working at the kernel level and in the kernel land, so if we are doing something, let's say if we messed up, so at the very least we will get something like kernel panic, and more like kernel can crash, and there are various repercussions to this if we kind of mess up into this. And another very important thing is, like, if we are using these kernel modules, right, so we can only inject or load a kernel module if it is compiled for that particular kernel, and that is a very hard requirement. So let's say ki, if we have a kernel, let's say it is let's say 6.5.0.1, right? If it is 6.5.0.1, and if we have a module that is for, let's say, 5.5 point something, so we cannot inject that 5.5 module into this 6.1, because it has to be the exact same kernel version it is compiled for, and that is one of the very hard requirements. Some commands of which actually relate to this are ins mod, insert module. This one, this is used to insert the module. This is used to remove the module, and this mod prov is kind of managing the modules, like starting it and configuring it to run at the kernel boot time or load time. Anyway, so this technique is also kind of very tricky in another sense that it requires the root privileges. So if we are non-root user, we cannot touch the kernel. And if you look into this image here, so you can see, like, this is our hardware, whatever laptop or whatever motherboard or whatever PCI equipments like RAM or whatever things we are running. So this is our hardware. Below hardware, we have the kernel code. This is essentially our kernel, and this is the system calls. So essentially, how a user can access the kernel is they can only access via the system calls. They cannot access the kernel directly. So when we are running in the user land, that is, let's say your whatever user interface you are using, let's say you are accessing the SSH or whatever. So that is the user land. The kernel is something else. It is kind of the strictly at a very lower level, and user cannot access it directly. So how we access it is, we use these system calls to interact with the kernel, and kernel in turns interacts with the hardware. So this is kind of the flow here. And you can see like this is the user space, this is the GNU C library, GNU-C library, glibc, and this is the system call, like this is the kernel land. And another thing about the kernel modules I forgot to mention is, if we are working with the kernel modules, so since it is running in the kernel itself, right, so we do not have access to the standard C libraries. So for example, like if we are writing something in the C, we can use something like let's say stdio or conio, stdlib. So if we are working with the kernel, we do not have access to these libraries. So essentially, we are using only the libraries which are included with the kernels, and those libraries are a bit um, harder to navigate. But if you kind of go through this, like this is a very fun topic, Linux kernel. I have started it recently, but I have been liking it the more and more I learn about it. So it is something very fascinating if anyone is like interested in this sort of things. And another thing that is very interesting or very kind of fun is it is entirely written. The Linux kernel is mostly almost 90-95% of the kernel code is written in C itself. So only C is used, and some inclusion for Rust is like undergoing. So some of the things were I think written in Rust. Still, it is Rust is not very much uh, adopted yet, but it is C. So if anyone is willing to learn C, it is a very good way to practice with the Linux kernel. Like it will be a complete brain boom, but it will be worth it. Like anyways, moving on. This is the kind of the Linux kernel diagram. How Linux kernel essentially works. It is a very trimmed down diagram, and there is one very good diagram available at the same link. You just have to change these. Anyways, if you go to this makelinux.net, I think you will find it. So I forgot to mention earlier one other thing. So this webinar, it is kind of a part of a series. So in this one we are kind of covering the basic things and just kind of giving overview kind of things, and in future we are planning to include or kind of have like in-depth webinars on topics like Linux kernel modules, Linux kernel, some of the other sneakier things. So, and we are also planning to publish a blog with some of the detection techniques. So, anyways, keep an eye out for our socials and our website. So, this is moving on. This is the kind of the kernel diagram. We can see like our hardware is at the very low level. So this is the hardware, like whatever it is, like CPU, RAM, our PCI buses, our keyboard, mouse, display, audio, microphone, speaker, whatever. So it is at the very lowest level. And in this side, if we see that there is like SSDs and this NVMe slots and this Ethernet Wi-Fi adapters, physical adapters. I'm talking about the physical adapters, not the virtual ones. So so let's not call them adapter, let's call them cards. So physical network cards and whatever. So these are at the very low level, and before these there are the kind of the ways through which they actually interact. So if it is a physical devices, it cannot interact on its own. So we have the interfaces which we use. So for this we have the peripheral drivers, so we have the keyboard drivers, mouse drivers, audio drivers. For this PCI buses, we have the bus drivers for the, let's say, USB devices, or let's say for the other PCI devices. For the CPU, we have interrupts, and like for the RAM, we have the page allocator, and so on and so on. Before this, there are the kind of the high class drivers, and like these are the modules, or these are kind of the actual things which are kind of the logical segment of this. On top of this we have the bridges through which like different kind of different sections interact or intercommunicate with each other. Above them we have the file systems, we have the user space like interfaces, and these are kind of the things through which user directly interact, and this is the functions, right? So this is let's say this, let's assume this is the human level. So if you are interacting with this, so we have different like drivers. Like if we talk about the Linux kernel modules or Linux kernel, so we have different drivers. So we have character drivers, which kind of read character by character. We have the block drivers which read block by block. So anyway, so we will try to cover these in depth in the future webinars. So for this, let's keep it short. So essentially, we are seeing that the system calls is used to do this, the socket is used to interact with this, the file and directory is used to interact with the storage device, this memory access is used to interact with this, processes are used to interact with the CPU and leverage the power. System call is used for like interacting with the PCs and so on and so on. So this was kind of the brief overview of how Linux kernel is working at a very high level. So there is a very I had mentioned like there is a very good in-depth diagram available at the same site. Do check it out if you want. And now for the demo. So for this demo, we will not be looking into kind of kind of the persistence kind of thing. We will be using this kernel module for a different purpose. So let me show you. And we have started this listener. Anyways, so this is kind of a module. So it is open, actually open source. So there is I'll just show you the name of the guy. So he has a very good blog. I'm actually going through this blog as well. So it's on GitHub, I think. GitHub. I'll just show you. So this is the guy, the accelerator, and he has very good blog series on the Linux rootkits. So if you are interested in the Linux rootkit, I would recommend you to check out these blog posts at least once. So this code is also derived from that blog post itself. Essentially, what we are doing is like, and I had mentioned that in the Linux we do not have like in the working with the kernel modules we do not have access to the C standard libraries like stdio and conio and whatnot. So here we can see like we have included the directories which the header files which are essentially part of the Linux kernel. So we have init.h module, kernel, syscalls, TCP, and we are also including this one custom phrase helper. So essentially, what this particular code is going to do is it's going to take this one particular port, this 11337 port, and it is essentially going to hide it from the system processes. So I have compiled it, and I had mentioned that you have to compile it for the exact same kernel version, right? So let's check the kernel version. So I have this kernel version running right now. It's 6.5.0 and TAC 1022 AWS. So this is the kernel version. This system is running right now. So we have started the listener here, right? Now let's execute. Okay, what I'll do is I'll quickly start because I do not want to type that much. So I'll quickly start, or what I can do is let me type, no worries. Open SSL. Where did you go? Open SSL 13 dot. Is this dot? I'm running this, and this process is backgrounded because I have used this to background the process. And if we go here, we can see like we already got a shell here. Who am I is Ubuntu. Host name is Linux persistence. Now what I'm gonna do is I'm simply gonna detect this. So there are a couple ways to detect this in the OS query. So where is the OS query? Yeah, so we have one command here which we ran before, and it is showing that okay, this is this, like this is running here, this is running here, this is the port, this is established, this is connected. So essentially, we ran this. Now, what we can do is let me clear this. Now we can see like we have different files which were compiled. So let's do it one more time. Let me run the cleanup.sh. And let me make it, let me compile it again. And we can see like it is compiling for this particular kernel version, this particular kernel header version. And it is compiled. Again, we list the files. We can see like we have different files. The file we are interested in is this hiding ports.ko. So ko is kernel object essentially, and we are inserting it. Now we are inserting it, right? And before inserting it, let me do one thing. I'll be running this one more time. So you can see like this is again listing the processes. Now I'm running this. This module is inserted. Let's check. So we can see like a verification failed. It is not required. Like this is actually something we will be talking about in the next webinar. More about this, like why this error is giving like signature failed and tilting kernel. But you can see like the rootkit is loaded. Now, if we run this command, same command, we can see we are not getting any output. Like it's simply blank. While if we go here, this one, let me run who am I again. Let me run hostname again. Let me run sudo again. Let me run who am I again. So I'm able to execute the commands. I'm in constant touch with this particular server, this victim server. But this this OS query or these tools, they're not able to detect it, and that is because we are essentially invisible at this point, because we are essentially kind of everything like this is kind of controlled by the kernel itself. If we look from a very high level, right? So essentially this is still happening. Essentially this is still working, but we have written a module, and this module is hiding it. So this is the beauty of the kernel modules or working with the kernel itself, because we kind of get the kind of the superpowers that we usually hear in the Spider-Man movies, like Mary Jane is like with great powers come great responsibilities. So this is actually a great power, lot of responsibilities as well, because we can crash the kernel, we can damage data, we can essentially break the system. Anyways, let's clear this, and also let's check the module. So we can see like our module is loaded, it's here, and this ls mode command, it is listing all the kernel modules. So we have the tls this, but our module is here at the very top. And now let's like remove this. So we are removing this module, and before going there, let's check again who am I is root, hostname Linux persistence, and let's check the modules, ls mod. So our module is not there, it's been removed. And if we check the message, we can see like it is unloaded, and here we can get something like this as port this. So we'll talk about these in the later webinar. So right now we ran this command, but we didn't got any output. Now we are running this command and we are getting the same output. So essentially what we did with that module was we hid this particular port or this particular connection from the kernel. Like it's still detectable, I think, but I haven't looked much into it. So maybe you can come up with something to detect these kind of things, or something to kind of mitigate. So anyways, so this was actually the last demo. So there is one other topic we will be touching, but we will not be kind of doing a demo of this one. So it is the shared library. So shared libraries are kind of if you have used Windows and if you're familiar with the concept of DLS, that is your dynamic link libraries. So essentially this is the counterpart of DLL in the Linux. So in the Linux we have the shared libraries or SO. You can see like the something like .so. So and that is a library which is shared by different commands, or not commands but different applications whenever they are executing or whenever they are kind of loading or starting or running. So it is kind of libraries shared among the applications. So we can compile, let's say we compiled one shared library and we wrote 10 programs which are depending on that library. So we can do that, something like that. So these libraries are essentially loaded by the program when it is about to run, or when it is running at the very runtime. It is actually loaded before, but anyways, that is something we'll also look into the later webinar. And this process is controlled by some of the environment variables, which usually start with LD and underscore and RTLD underscore. So if you have heard about something like LD preload, so that is also something that is used for persistence using the shared libraries. And you can see like we have some common environment variables like LD library path, LD debug, etc. So for this, I'll simply show you something. So we can use one command, that is LDD. It is our kind of dynamic linker, and we can run it for any of the commands. So let's say run it for etccat. Sorry. Yeah. So if we run this LDD on any of the binaries, so we can see like there are different shared libraries: SO.1, SO.6, SO.2. So these are essentially the libraries that are being used by this particular application, but it is not only exclusive to this application itself. So it can be used by other applications as well. So if we do something like, let's say, LDD and bin dash, so we can see like this libc6 dot so, right? This libc6 by so it is also used by this one as well. This cat is also using this, bash is also using. So this is kind of the things that are shared libraries are used for. And it is also a very good way to do this. Like let's say if we got into a system, right? And if we figure out like, okay, so they have Apache, and Apache is looking for essentially a service like this, a shared library, right? So essentially what we can do is we can create a shared library. We can include our own backdoor into it, and we can replace the system library with this shared library, right? So every time Apache is running it, so our backdoor is also getting executed. So it is a bit hard to detect from where I'm standing, but there might be other ways to detect, because I'm not much into the detection portion yet. So I just know the kind of the basic things, kind of the new ways to do the kind of the detection kind of things. So still could be ways. If you find ways, do share on our LinkedIn or Twitter. Like just comment in the same post. We would be happy to kind of receive your inputs. So with this webinar is coming to an end, and I'm sorry we took some more time. I think we went overboard by half an hour. So again, apologies for that. Hope you guys like the webinar. And we're also giving one course, that is a certified process injection analyst, CPIA. So details are already on our LinkedIn, and I think Nani ma'am also told you in the beginning of the webinar. So the webinar is officially ended. Now the time is for the Q&A. So I'll be looking into some of the questions you have, if you have. And I really hope you guys like this webinar, and looking forward to kind of continuing with this. and I'm really excited to look into the kernel things, and hopefully in a future webinar we'll look into these things together. So let's check the questions. So if you look into the chat, so there is one link there with the link for the LinkedIn where you can still participate. So I think it is still valid. So if you haven't checked it out, so check it out, follow the links, and do the needful. 5-7 lead start, 20-minute extra ending. Yes, yes, I realize this is not a good impression. Actually, I wanted to finish it before, but like these kind of things, I'm pretty excited about, so I kind of extended. So, but yeah, I mean, in future, like I'll try to wrap it up within the time limit. So OS query works for Kali as well. OS query works for, I think, all the OSs. So be it Windows, be it your Unix, be it your Linux, or like when I'm referring to Unix, I actually mean Mac. I'm not sure if it works on the Unix, pure Unix, but I have seen it for the binaries for the Mac, Windows, and Linux. So what you can do is you can simply go to, I think it is osquery.io. I think, let me check. So it's osquery.io. You can check it out. So you have binaries for different OSs. You can simply use it. Keep in mind some of us take time, and yes, I do apologize for that. And in future, I'll try to wrap it within the time limit. Yeah, this open VPN trick is good. I mean, this was a very quick demo, and I mean there are measures in place actually to prevent some sort of things. But yeah, like I'll consider this one. And thanks for the suggestion. Is it possible to get the presentation slide? Yeah, already answered. Is this the latest version of Ubuntu? Yes, it is. I mean, if you talk about latest, it is 22. Latest is 24. I do not like 24 as of now. I have had really um, not good experiences with the 24 when I was working on a project. So I use 22. It's more stable. Hello, is the same session scheduled to start? So I think these are all the questions. I cannot see any other questions. Okay, okay. I cannot see. Will we are getting CPI now? The giveaway is, I think, still undergoing, so you can still participate. So I'm not sure when we will be revealing the results, but you can participate and check how to build career in cybersecurity. This question, I think you're better off, researching what are your interests, and figure out which kind of domain you like offensive, defensive. Because see, cybersecurity is very vast field, and I do see these kind of questions like how to build. So first of all, I'll speak from my experience, because for everyone it is different, and everyone has kind of different paces or different ways to learn or kind of do things. So for me, it actually started almost a decade ago. So I read about Stuxnet, and it was something very interesting. And before that, I had been like kind of the IT guy for my family, but still that Stuxnet, it was very interesting thing I found. I looked into it, I read about it, and that was kind of the pushing point for me. So from there, I kind of learned, experimented. Yes, so whatever I'm showing, it will work on the latest Ubuntu, because essentially we are not exploiting any vulnerabilities. We are simply using some of the tricks, and we are not using any direction like prevention methods, like measures like UFW or something like this. So it should work. So Anand, pen testing, I mean, just check out our blogs. There are some other good blogs. So I think if you look into TCM security, they have like kind of very good videos, and even on their YouTube and their blog. So I think you can check it out, research it out, figure out. I think that would be good. And if you are looking into the pen testing, I would highly recommend you to kind of figure out one uh, portion where you want to specialize in or where your interest are, because pen testing is also very huge. We have like network, web, we have hardware, we have like physical. So just figure out uh, your interest and you will be good to go. So I think with this we can wrap up the webinar, and it's 30 minutes late. So once again apologies, and hope you guys like the webinar. So yeah, with this we are wrapping up the webinar.